In this lecture, we're going to learn about destructors. Destructors are special functions or methods in a class that are called by the compiler to destroy your object. And these are going to be especially useful if you are, for example, allocating memory in your constructors. Let's look at a simple example. Here we have a class called dog. It has two sections, the public section and the private section. In the public section, we have two constructors, a default constructor that doesn't take any parameter and a constructor that takes two parameters in. The parameters are going to be used to initialize our member variables, and they are passed by a value here for simplicity. And they are going to be used to initialize these member variables, dog name, dog breed, and dog age. The special thing about this class is that it has a destructor, and you declare the destructor using this syntax here. You put a tilde character in front, you say the name of the class, and then you put an empty parameter list. It is also possible to declare a destructor and put in its entire body in the header, and this is the syntax to do this. Inside the body, you're going to do whatever it is you need to destroy your object. For example, if the class here is allocating some memory in the constructor, the destructor is the best place to release that. And this is an example of how you can do that. Here is a more direct example of how we allocate for dynamic memory in the constructor and release that memory in the destructor. We have our three variables, but we have chosen to allocate our dog age variable on the heap using dynamic memory allocation. And after we dynamically allocate a piece of memory to store our age variable, we're going to set that to 0 because we are in a constructor. If we are using the 3-param constructor here, we might use the passed parameter to initialize our age variable. But the important thing here is that it is being dynamically allocated memory on the heap here. And when our object dies, we need to remember to release that memory. And the destructor is the best place to release that memory. As you see here, we say delete dog age when our object dies, and the compiler is going to call this function when it's about to kill the object. So you might ask, when are destructors really called? We are going to start by looking at obvious cases here. For example, when a local stack object goes out of scope, the destructor is going to be called because that object is going to be wiped out from memory. So this is an obvious case in which the compiler will need to call a destructor. Also, when a heap object is released from memory using delete, the destructor is also going to be called. But there are some indirect ways in which destructors are also called. For example, when an object is passed by value to a function, this is going to call the destructor to kill the object when the object goes out of scope in the function. Because when an object is passed by value, we're going to have a copy in the local scope of the function, and when the function exits, that local copy is going to be killed. And we're going to see an example of that. Another case where you might have the destructor called is when a local object is returned from a function. Another copy is going to be created to be used outside the function, and the copy inside the function is going to be killed. But this is not guaranteed, as some compiler may optimize your return value and use some kind of reference. So you're not guaranteed to see this behavior, but it is possible to see it. Now that you have an idea about destructors, it's time we headed over to Visual Studio Code and play with us a little more. Okay, here we are in our working folder. The current project is Destructors. We're going to grab our template files pretty quick, and we're going to put them in place. And after that, we're going to open our folder in Visual Studio Code by dragging and dropping here. This is going to open our folder, and we will see our main CPP file here. We can open it and clean up and remove what we don't need. We have an unneeded breakpoint here. We can remove that. and we're going to clean up the main function. The first thing we want to do is to put in our dog class. I am going to just put this in here because I don't want you to watch me type all this. That's just going to waste your time. We have two sections in the dog class. We have a public section, which is going to now contain our constructors, and we have a private section, which is going to contain three member variables. We have two strings, one for the name and the other for the breed of our dog. And we have another one, which is an int pointer, which is going to store the age of the dog. And you see that this is initialized to null pointer. One thing you should notice is that for our parameter taking constructor, we are passing the string information here using string views to avoid copies with the std string view type. You already know this because we learned about this. But for this to work, we will need to include string view. So let's do that. And now we have our class and we can use it however we want. But before we do, we need to put in the implementations for these functions. One way we can do that is do that directly in the function here, but I want you to see that you can also do that directly outside the class here. I don't think I have shown you this, but it is possible to do that. So we're going to grab the prototype for our constructor and say the scope resolution operator, and we're going to just paste in what we have copied, which is the prototype here. And we're going to go inside, put in our body, and in the body we're going to initialize these three guys. So the name is going to be initialized to name param, and the breed is going to be initialized to breed param. We can do that. And the age is going to be dynamically allocated from the heap. You see that it is a pointer. So we're going to say ph equals new int because we're going to allocate dynamic space to store an int. And we're going to put data in using our good old dereference operator. We're going to say ph equals whatever ph param they passed. And I think we should say age here because it's not a pointer. So we're going to say age. I think this is going to do better. Age param. This is probably going to be better. And we're going to say age param. Okay, so now we have our constructor n, and it's going to allocate memory from the heap. And we're going to put data in that new memory location that has just been allocated to our class here. So this is our class, and we can go in the main function and really use it however we want. For example, we can set up a dog object. So we're going to say my dog, and we're going to give it a name. The name is going to be Fluffy, and we're going to put the breed in, and it's going to just be a shepherd. And we're going to put in the age, which is going to be, for example, a 2. Let's say our dog is 2 years old. This is valid C++ code. It's going to be setting up an object of our class here, and we can build to see that this program is going to build without a problem. So build is good, but if we run the program, we're not going to see anything. But we don't really need to see our constructor here called because we already know about constructors. What we want to learn about are destructors, and these are special methods that are called by the compiler when your object dies. Let's set up a destructor and see it called when our dog objects die. The syntax to do that is to use the tilde character here. You're going to say the name of the class. You're going to put an empty parameter list. And if you want, you can put a body and do whatever you want to do in the body of your destructor here. But again, we're going to move the entire definition of the destructor to the outside. So let's go down and save that. We're going to say the scope resolution operator. We're going to say dog, and we're going to put in our body. And the first thing we want to do in our destructor is to release this memory that was dynamically allocated for us. If we don't release it when this dog object dies, we're going to leak memory, and that's really bad. So let's do that directly in the destructor. We can say delete and say ph. This is going to release the memory that was allocated in the constructor here. And we have access to this ph variable because the destructor is part of our class. Any member function of your class is going to have access to any member variable, even if it happens to be private. Okay, so we forgot our tilde character. Let's put that in here. And this is going to be valid C++ code. But to really see things happening here, Let's put in an stdc out statement. We're going to say dog destructor called for, and we're going to say the name of the dog. Let's say name, and we're going to say the same thing in the constructor. We're going to say stdc out and say dog constructor called for, and we're going to say the dog name. We're going to use our member variable, and now we have our thing in place. We have the destructor declared in the class definition, and this is the syntax again. This is what we really want to learn about in this lecture. We have the tilde character, we have the class name, and we put an empty parameter list. Let me tell you that it is not possible to pass parameters to your destructor. If you do that, you're going to get a compiler error. Destructors will always have no parameters in C++. Here we have the definition of our destructor, and it is going to release whatever memory we have dynamically allocated from the constructor here. If we run this program, we're going to see our constructor called as a result of this line here, because we are constructing a dog object, and we're going to see the destructor called when the main function is about to end. Let's put an stdc out statement in the main function here and say done, just to prove that we have hit the end of our main function here. I think this is useful, and we're going to build. So let's do that. We're going to build with GCC. You're going to see that the build is good, so we can clear and run our program. Let's hit enter here and clear and run rooster. You're going to see that the constructor was called. We are going to say done when the main function is about to end, but before the main function ends, we're going to destroy any stack data that we have in the main function. And our dog object is on the stack, so it's going to be destroyed as part of that process. And the destructor for dog is going to be called, and we're going to release our memory, and we're going to say that dog destructor was called for whatever name we have assigned to our dog here. So this is how destructors are called when your objects are killed. And we didn't put in the correct name. We said Fluffy. Let's say Fluffy because that's what I wanted. And now you see that our destructor is really being called and releasing memory however we want. But we can also go a little further and show you another example of a case where destructors are called. And we're going to look at a function that sets up a local object of a dog. We're going to see the dog constructed, and we're going to see it destroyed when the function is about to end. Let's do that. We're going to say void some func, and it's going to be just some function to play with us. We're going to move our dog declaration in some func here, and this is really it. We're going to call this function, and when we call it, we're going to construct the object here. When the function is about to end, the compiler is going to call the destructor because it's going to destroy this object here, and we're going to see the destructor called. By that point, the SumFunc function is going to be popped off the top of the stack. We're going to hit the main function here, and we're going to say done, and the program is going to end. Let's call SumFunc in main here. So we're going to say SumFunc, and we're going to build to really see this happening. So we have built successfully. We can clear properly and run rooster. We're going to see constructor called for Fluffy, destructor called for Fluffy, and you see done. We have hit the main function and really finished executing our program here. We can even see this through the debugger. We're going to set up 3 breakpoints, one in the main function here before we call the SumFunc function. We're going to set up another one in our destructor before we print the message here, and we're going to put another one in the constructor when we are about to print this message here on line 20. After we set up these breakpoints, we can kill the terminal here and minimize a little bit. Let's kill these things here so that we have a clean, we have a lot of windows here. Okay, we have our editor here. And now if we go to the tab here that says start or run, we're going to be able to click the green button here to start our debugging session. We are going to have our terminal here, so let's bring that to the side so that we can see things printed out nicely. Let's do like this. And now we have hit the breakpoint in the main function. We can step into the SumFunc function, and we're going to do that using the step into button here. Let's click that. We're going to jump into SumFunc. Now we have the option to step into, but this is going to jump us into the logic of transforming the string literal here into a string view, because if you see, the constructor is going to take string view parameters. We can actually see this. Let's try and hit the step into button. You see that we are in the string view class and we don't really want this. So let's step out and we're going to step over this so that we can hit the next breakpoint. And you see the next breakpoint is in our constructor, and this proves that the compiler is going to call our constructor here to build our object. If we step over this, we're going to print the message from the constructor, and if we keep going, we're going to get out of our constructor, and you see where this is going to go. This is going to go in the destructor, because before we leave the SumFunc function, our dog object is going to be destroyed. So we're going to release our memory and we're going to print the message from our constructor. And if we hit next and step out of this, I think we can do that because this is logic we don't want. We're going to try and step over this. And now if we hit next, we're going to come back in SumFunc, and SumFunc is already going to be finished. And if we hit next, we're going to come back in main and we're going to print done. And the program is basically going to be done. Hopefully you can see that the compiler is going to call our destructor after it leaves SumFunc here, because it's going to be destroying the local object that we have inside SumFunc here. So this is one case where the destructor is going to be called by the compiler. And it is if you have a local object that needs to be destroyed when function scope finishes. Another case where the destructor may be called is if you pass a class object parameter by value. So let's change SumFunc here and make it take something by value. So we're going to pass a dog inside, and we're going to say dog param. This is going to do. Okay, now that we have changed SumFunc here, we can really do all kinds of crazy things with it. For example, we can set up our dog object inside our main function here. So let's do that. We can say dog and dog. The variable name is going to be dog. We can give it a name which is going to be Fluffy. It's going to have a breed of Shepherd, and we can give it the age of 2 like we have been doing all along. We can call our function with the dog object here, but be careful about what is going to happen here. When we do something like this, we're going to be passing by value, and the compiler is going to see that it needs to copy a dog object. Now, we haven't really told our class here how to copy dog objects. And we do that through constructors we call copy constructors we haven't really learned about yet. But what the compiler is going to do by default is copy these things member by member. So it's going to set up a dog copy object, which is going to be initialized with empty strings and a null pointer here. And then it's going to copy from our dog object that we have here. It's going to take the name and copy that in the name member variable of our dog copy. It's going to take the breed and copy that in the second member variable here. And it's going to take the age from our dog and copy that in. The problem is going to come to this pointer here. It's going to copy the address, and it's not going to copy what is pointed to. And this is going to be a recipe for a disaster. I don't really want to go through this right now, but if we try to run this program, it's not going to work like we expect. For example, if we pass Fluffy here, we're going to see things that we don't expect. So let's try to build. We're going to build with GCC, and the build is good. So what we expect is to have the constructor of Fluffy here called, and we're going to copy the dog object for use in SumFunc here. And to set up this copy, it's not this constructor here that is going to be called. So it's not our constructor here which is going to be called. So we're not going to see this called for the copy that we set up inside SumFunc. Another thing is, because now these two dog objects are pointing to the same thing, because what we just copied is the address as we see in our member variable here, the two dog objects are going to be pointing to the same thing in memory. And when we hit the destructor, we're going to call delete twice, and this is going to be a recipe for disaster. Our application could really crash. You already know that deleting a pointer twice is really bad. We shouldn't do this. And we are doing this here because we are copying. I realize this is a slightly confusing example, But what I want you to know is that if you pass a class object by a value like this, the copy you have inside is going to cause for the destructor to be called when the function exits, because the copy is going to be scoped inside the function here. So let's take out this example because it really is confusing, but I hope you know that. And I am going to show you that another case where you might see the destructor called is when you call the destructor explicitly using the delete operator on your object. So we can set up some func again. Let's do that. Some func, and we're going to repurpose it. And inside, we're going to set up a dog object. So let's grab this and reuse that in our function here. And we're going to say dog pointer. So let's say dog pointer. We're going to say p_dog, p_dog. It's going to be equals to new dog. And we're going to pass in what we need to initialize our dog object with. This is going to create a dog object on the heap, and it is going to be pointed to by p_dog here. Now, I want you to see that if we don't explicitly release the memory that we allocate through the new operator, we're going to leak memory. So we created an object on the heap here, but we're not deleting that in some func. When some func exits, we're going to lose this pointer, this variable, because it is on the stack itself, and we won't have any way to release this memory. Let's call some func here and really show you this. So we're going to call some func and we're going to build. Let's use GCC for that. The build is good. We can bring this up a little bit and clear and run rooster. We're going to see that the constructor for Fluffy was called because of this new operator, but we didn't see the destructor called, and this is really bad. So for the destructor to be called, we need to explicitly release the memory in this function here. And we do that by using the delete keyword and saying the pointer that is pointing to the memory that we want to release. If we do this, this is going to cause for the destructor of dog to be called. And if we run, we're going to see our destructor called. Let's do that. We're going to use GCC. The build is good. We can clear and run rooster. Now you see that the constructor is called for Fluffy and we have the destructor called. This is really all I wanted to share with you in this lecture. I apologize if you found it confusing, but if you have any problem, I am always available. Please do ask and I will do the best I can to help you out. So the destructor is a special method which is going to be called when your object dies. It is going to be called when an object is passed by value to a function. We have seen an example of that. It's going to be called when a local object is returned from a function by value, but this is going to be compiler dependent because some compilers are going to optimize this out and make it look like you returned by reference. So I don't want to go into this because this is subject to compiler optimization, but other cases where you're going to have your destructor called is when a local stack object goes out of scope and when a heap object is deleted through the delete keyword. This is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one. And the next one, we're going to see the order in which constructors and destructors are called. And you really need to be aware of this. Go ahead and finish up here and meet me there.